All right, so today we're going to be taking a look at how to implement a program for writing information from your computer in a Java program through a USB cord or cable into an Arduino or other kind of microcontroller that's similar to an Arduino with a USB serial interface to it. Okay, and then on this, in this particular case, on this Grove Beginner Kit, we're going to try and display a countdown on that little OLED display right there. Okay, so here we go. We're going to create a new project. And we're going to go next. This is Java SDK 14. Next. So F serial Arduino version, I don't know, 12 at this point. All right. And then in here, we're going to create a new class. We're going to create the main class. Like that. And this is where we're going to initialize things and get stuff started. Now, the main class I described earlier in another video, and so basically it's a main file, main.java. It's got a class called main with a capital M. We're going to have a method called main with a lowercase m inside of it. We're going to describe the number of times we're going to iterate through basically a loop to send data into the microcontroller, and then this method is going to do things like set up a serial port object, configure it, create a data stream for that serial port object, add in some other things. We'll get into that, okay? So what we have to do is we're going to have to do some importing to begin with. Okay, so we need a couple of things. So we're going to import com.phasecast.jserial com.serial port like that. We could also do something like this. We could go like that for everything that we wanted to bring in. Okay, so import java.io file not found exception. Import. I can't remember if we actually. I don't think we need that. Anyway, well, we'll put it in. We'll put it in and dot file output stream. Import java.io exceptions. Oops. Come on, we can do it. There we go. All right, then we're going to put in import java.io output stream and import java.util.timer because we're going to have some timed tasking going on here. All right, so we got our public class. And then inside of this, and you'll notice all these are great because we haven't actually implemented any of these libraries in the code yet, okay, or called them in. So how many times to run a timed scheduler? All right, public state final. We're going to have it of type byte. Timer duration is equal to 10. So we're going to talk to the serial port with this USB cable 10 times, all right? And or we're going to count down 10 times, and then we're going to send a final signal saying we're done. Next, we need to have a main method, okay? So we have our main method like that, and then inside of it, we are going to name the serial port. Now, to get the right name for the serial port, you need to, well, there's a couple of different ways to get it, but one way is to go into the Arduino IDE and figure out using port what that's connected to on your computer, and it's different for many different machines, so you have to go and do that first. In my case, we're going to take a guess at the type for this variable, this object, sorry, right here, SP, and we're going to say serial port dot get com port, and this is going to be /dev cu dot slab USB to UART. Now, to get that, you actually have to dig around in your Arduino IDE to figure out what this string is right here. Now, we're seeing a bunch of red right here. Okay, oh, right there. So what we need to do, oops, and that should be static, not state. Static, right there. Okay, so serial port. So what we got to do is we have to go and import the serial com library. So we go to File, Project Structure. We're going to use Maven to get access to it. Now, library right there. I'm going to go plus from Maven. Now, Maven's asking which serial port program do we want. Now, if I go jserial .com, it probably won't find it. It used to find it, doesn't find it anymore. So instead I'm going to go into Firefox and I'm going to go Maven JSerial.com because that's what we want. I've got to figure out what it's called. So let's see. Actually, no, I shouldn't have. I should have just done Maven search. Let's do it like that, just for general searching. Okay. So we're going to go JSerial.com. That we can see it. I hit enter, and we can see that it's com.phasecast and JSerial.com. So to call it in here, we go com.phasecast : JSerial.com like that. And you can click on the search icon right here, or I think you can also go like shift enter or something like that, and it should find it. There we go. So we found it, and we want the latest one, so 2.6.2. We hit OK. We say we want to import it into as a module. We go OK like that. Now the red should go away. There we go. The red's gone. Fantastic. So we now have this object SP, which is the serial port object, and we've assigned it the COM port. Okay, so it knows where to look for serial port signals. Next, we want serial port to be at 9600 baud and a bunch of other standard things. I'll show you in a sec. All right, so we're going to go sp.set COM port parameters, and we're going to go. We want, let's see, 9600 baud. Then we want to send in packets of like that, so bytes. So little short little things. Serial port dot one stop bit. Okay. It's a standard for serial communication where we take, say, the number of bits that we have, and one of them will be associated with. Anyway, it's a special signal. So we have one stop bit, and then we've got serial port dot, and we want no parity. Parity is like this error checking business, and we don't want to do that. Okay, then we're going to go set. We're going to do serial port SP set COM port timeouts. Serial port dot timeout write blocking. There we go, like that. 0 and 0. Okay, so we want 0 timeouts. Okay, now we want to attempt to open the serial connection via USB. Make sure other programs with serial USB access to the board are shut down. Okay, or closed. They have their connection disconnected. So real term, hyperterm, cool term, the Arduino serial monitoring program, etc. You have to make sure they don't have an active serial connection to that board right there. Okay, it's really important. Otherwise, your Java program will fail to connect with it because only one program can be connected over the USB at a time. Okay, so we're going to do var. So we're going to guess at the type. We're going to say has opened is equal to serial port. And we're going to try to open the port. Okay, like that. Next, if we're going to take a look at the flag, basically has opened, yeah, like that. And we're going to say if it hasn't opened, we're going to send basically an illegal state exception like that, and we're going to say we failed to open the serial USB port. Check other programs, hyperterm, etc. Okay. And I got a semicolon on the end of there. Yep. All right. So next up, I'll stay within the main method. All right, here we go. So next up, we want to define a data stream to send information into the USB line. Now, there's this data stream. It takes care of the niceties. Okay, like basically some extra things that need to happen in order to make sure the data is nice going into the USB line. So it's handy to have access to. So we're going to again guess the type. We're going to go output stream is equal to serial port get output stream. So we're going to use within the library for Phasecast's JSerialCom. You can see it right here. There is a method called get output stream. Okay, so I'm in the GitHub site for Phasecast. Okay, this is the documentation. It's always good to be able to take a look at the documentation, have it on hand. So in this particular case, get output stream. I'm going to click on it, and it says get output stream method returns an output stream object associated with this serial port, allows for easier write access to the underlying data stream, and abstracts away many low-level writing details. Sounds like a super convenient thing to use, take advantage of, so you don't have to make it yourself. So take this module, this block, this object, okay, basically, as it's going to be created here, and use it for doing useful work. Okay, this is again one of the really important things about an environment like Java. Is that a language like Java is that you can use these libraries to get important work done. Okay, so in this case, we're trying to talk to this Arduino, but that's because in engineering and science applications, you can have data acquisition applications, instrumentation applications, you can have mechatronic applications, all sorts of things where the PC has to talk to an Arduino or a microcontroller board. So we have our data stream, and next, just in case at runtime, we want to close down nicely. Okay, so when it's time to shut things down, we want to make sure that the thread that this program will be sitting on and working on inside of the operating system on your computer, we want to make sure that when it's time to shut down, it shuts down nicely. So we're going to do something. Now, it's going to look complicated. It's basically using an inline function called a lambda, and I'll show you how that's done right here. So we go runtime dot get runtime add shutdown hook. You don't have to know this. You just need to know for the time being how to do it. Okay. So here's the lambda right here. Now we're going to go try, because there's two choices here. Okay. The first one here is we want to attempt to close the data stream. And we do that by output stream, and then we do close like that. Okay, and that should close the data stream, and that's good. Okay, and then it cleans it up afterwards. And we go catch IO exception in case there's an IO exception. Okay, something can happen, and things do happen, right? So we take that exception that's been that parameter that's been passed in, and we go print stack trace like that. We can say it like this. We can also say something like, we had a problem shutting down the program, and then we can see what it is in the stack trace. Okay, basically the error messages that the program will send out. Now, once that's done, so hopefully the stream has been closed, then we still have to try really hard to close the port. So we do, this is the serial port. We have to close the software connection to this so that other programs can grab it once we're done. So we go close port like that. All right, and this closes the serial USB port connection to the Arduino or Arduino microcontroller board. Okay, and that's all done right there. So next up, we need to create an implementation, an instance of timer class. We're going to call this timer, and we're going to do the same thing. And this is going to be of something we're about to do called countdown handler. And if we do it right, IntelliJ is going to do some really interesting things right here. It's kind of neat. Okay, so we have the countdown handler. Okay, and we're going to call this countdown. That's going to be the object that's going to be created. Okay, and we're going to use the var keyword to guess at the type. Okay. All right, here we go. So we go var, var timer is equal to new. So we take the timer class and we're going to create a timer object, lowercase t, timer object, like that. And then we're going to go var, count down is equal to new countdown. It doesn't know what this is. Timer duration, timer output stream, like that. All right. And then run the scheduler as many times as requested. That's that final at the very top of the main class. And we're going to do it timer.schedule. Yep. Countdown is what's going to be passed to it, 0 and 1,000. So 0 delay and 1,000 milliseconds between calls to the task. The task is countdown. Okay, so we're going to pass the task to it. It's going to then run without a delay once every 1,000 milliseconds, okay, until we're all done. Okay, and once all that's done, then things will run until they're done. Now we have a problem here. Okay, it's all red. What's this? So IntelliJ is asking if we should create a class called countdown handler or create an inner class called countdown handler. Now, I had some discussions with Richard, one of our TAs, about this, and his suggestion is not to do an inner class, but to have a separate file that has the definition for countdown handler. Basically, we want to separate it out so it's a sort of standalone module. Okay, so that's what we're going to do right now. We're going to create a new class. And let's see, we're going to call it, there we go. That. So I'm calling my package ca.yorku, and I think it will add it. Yeah, it included it in main as well. It should be. Yeah, and now it's going to import countdown handler. So this, it did it for me right here. I didn't have to do that myself. Now where did it go? Right there. All right, so package that, import. It's importing these because it knows it needs them because I set up the countdown handler code in main. So let's go. Let's do this. All right. So public class countdown handler. Okay, now what we want to do is we want to do this so that it extends timer task. And the timer task was just added. Okay, so and the reason for this, we talked about this in the other video. Okay, so what we're doing right here is we're doing countdown handler.java. We are extending Java util timer task. So we're taking basically a plan for a class that's found in the timer task library, and we're creating a new version of it. Okay, that we're going to call countdown handler, but it's going to have the same sort of properties as the class plans that we had in Java util timer task. All right, so we're going to follow this right here. So we're going to have a constructor in it here. We're going to use the timer tasks run method, but we're going to implement it within our own version of the class. Okay, so that's what we're going to do now. All right, so here we go. So countdown handler is the name of the class. Countdown handler right here is going to be, let's see. Yeah, this is going to be the constructor right here. Yeah. And then we're going to have a method in here, and we're going to override the original method called run. So override, oops, like that. Public, oops, no output. Void run. There we go. All right, so there's the constructor right there. And just before the constructor, we're going to set up a couple of variables. The set of private variables that are used just internally. So private, we're going to have one called n, and it's of type byte. Then we're going to have private final, let's be a constant, so it won't change. Output stream output stream. So the type is output stream, and the object itself, the thing that I'm importing in, it's of type, it's output stream with a lowercase o. Okay, we're gonna do the same thing right here. Private final, so of type timer, and we're gonna call it timer as well. All right, so we got our timer, we got our output stream, and let's see, not stream. There we go. Okay, that's why I couldn't recognize it. Yeah, it will be initialized. Okay. Here. So now we're going to use this. So we're saying that this is, we use the keyword this inside to say that it's associated with our class right here. So this timer duration, because this is coming in from the outside. So we're taking this from the outside, and we're going to use it internally. This dot timer like that. So we're taking the external timer and we're using it internally as this dot timer, and then internally this dot output stream. We're initializing it using the output stream that comes in from the outside. Okay. There we go. That's our constructor. And the constructor is called when the object is called. Okay, so the class will be used to create an object, and when that object is called the first time, this constructor will be used to initialize it. All right, so we have that is done. So then inside of here, we're going to do a try. Oops. And then we're going to do a catch. All right, just like we mentioned in here. That's our constructor right there. And then our run method has an exception, try catch. So catch there, try there. And then inside we're going to have an if selection or conditional statement. All right, so try right there. Okay, now here's our if. Or actually, let's put the catch IO exception. Catch IO exception, and we're going to call this E, so we're passing in the E parameter. Yeah. Oops, I think I have too many of the, yeah. There's my catch right there. So we're just going to say, let me see. S out problem inside the countdown handler run method. All right, so just in case, you can say it out loud, and then we're going to say e.print stack trace. Okay, we'll assume that that red is not, oh, yes, right there, that's why. Okay, it was wrong. Okay, I had an extra curly brace. Okay, so then if, curly brace right there, else curly brace right there. So in the if right there, we go if this dot n is greater than 0, then that's normal operation, and we want to be able to print out to the USB. So we go output stream.write, and we're going to write a byte. So let's try that again. Write. And you can see that with the output stream, when I'm calling the write method, it says, it's assuming that either you can have an integer that's being sent or a byte. In our case, we're sending bytes. Okay? So then we're going to go like this. We're going to go this.n, which is a byte. All right. We could modify that code to send integers instead if we wanted to. This dot n is equal to, and I'm going to do this. What I want to do is, you could either do this dot n minus equals 1 to decrement it. That's one way to do it here. Okay. Another way to do it would be to do this. This dot n is equal to this dot n minus 1. Okay, but that's problematic because it assumes that the 1 right here is an integer. So what I'm going to do here is I'm going to then cast this to be a byte afterwards, so that this way, whatever the result of this is, it's going to be converted into byte form to update this dot n. Okay. Next up, we go this dot output stream dot. I know it's not the prettiest code, but it's just to be to explain things for those of you who don't know what the minus equal does. This dot output stream dot write. Okay, so in this case, the else right here is we're done and tell the Arduino. Oops. We're done. So the Arduino has some code that's running on it that will print out whatever you send to it, except if you send it -1. If you send it -1, it knows that you're done with the stream of data that you're sending to it, and it can go on and do something else. That's really important to be able to inform the Arduino that we're done with whatever stream of data we had. Okay, so we're going to go like that, -1 like that, and then we're also going to say this dot timer dot cancel. So if we're done sending data, we also want to close down the timer so that it's clear that we're actually done. Okay, so that's that. Then I got my catch. And I think we're done. We've got our countdown handler. We've got our main. I'm going to compile this and see what happens. Yeah, grab your coffee. Sometimes it takes a while. All right. And then once it's done, there's always something. Oh, here, hold on. Equals. There, I forgot a semicolon there as well. All right, let's run that. Let's compile it and see what happens. You know, there's always little mistakes like that. Now this is, granted, this is a really complicated program. So we're walking you through it so that you can see what it's like. All right. Now let's go over here. And we're going to run the main class right here. And we're going to keep an eye out for what happens on the OLED. All right. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, and then that -1 was sent, and we indicate that it was done. Now I'm going to bring it up closer so you can see it closer, okay? All right, let's do this again. We're going to run main. Six, 5, 4, 3, 2, 1, done. Okay, so you can see that this is possible to do it. It does take some doing. It is more complicated than doing this sort of thing on, say, for instance, MATLAB. But all that stuff in MATLAB was hidden under the hood. There's still a lot of stuff that's hidden under the hood here, but you're getting more general access to things. There's more flexibility for you to be able to create data acquisition programs, mechatronics programs, things to, in our case, in this version of the course, watering a plant, etc. This gets you going, and then we're going to go from here into other interesting things. All right. Hopefully you're able to follow along. Try it out. Try this out. Make it yourself. Walk along the process that I did, and you can see that IntelliJ will help you along, will prompt you for things as you are programming it up. All right, take care everyone, stay healthy, see you later.